Okay, this lesson is for Jude, and we're going to cover multivariables. And a lot of times what you'll see is you'll see equations with two, even three variables inside of it. Right now we're going to look at two variables. So let's take a look at some of those. So let's take a simple equation. Multivariable equation. And that simple equation is just going to be a rate equation. So we have a rate is equal to the metric, or what we're measuring, over time. So that metric can be anything. It could be distance over time. It can be, let's say, you are taking the number of steps over time. How many steps can you take in a minute? It can be how many problems you can solve over time. It can be any type of measurement that you can do that has a time metric on it, and that's a rate. Like, and you'll see that as we go through it. Let's take distance, because we do distance quite a bit, and that makes sense to a lot of people. Let's say we have a rate is equal to the miles per hour. Okay, that should be pretty familiar to you because you're in a car. And what does that mean? Well, let's draw it out. Let's draw a car. And it's going in a certain direction. And it goes a certain distance, d, and we're going to measure that in miles. And let's say it goes 10 miles, let's say 100 miles. Is the distance, and the time that it took to go that distance, let's say it took 2 hours. Okay, we got a rate equation here, and we have it set up, and we can actually say that as a, I forget how they have it in there, but it could be any unit. Let's call it distance over time. So a rate is distance over time, and that rate we know as either speed or velocity, right? So if you're going in a car and you're going 100 miles and it takes you 2 hours, how fast were you going? Well, let's find out. So we have our rate, R, is equal to the distance, which is 100 miles, divided by the time, which is our time metric right there, 2 hours. And you can see that's true because this is going to be distance over time. And in this case, we're doing miles per hour. So you can see that's what we have our problem set up for, distance over time. Distance is in miles, it's 100 miles over time, which is in hours, 2 hours. So here's the units that we're going to be looking for. Miles per hour, and as you can see, we got the right units here, miles per hour, and let's see what that equals to. So 100 divided by 2 is going to be 50 miles per hour. And we like to write that as 50 mph. And that's why whenever you see them talk about the speed of cars and how fast they're going, they use the abbreviation mph, which means miles per hour. So that's a rate equation. And so that looks pretty straightforward because we used the equation as written, right? So we're going to continue with the same type of equation, and it's going to be distance over time, and that's equal, I'm just going to write right here, R is equal to distance over time. So that's basically the equation that we're going to be working with for the moment. So now here's another way to look at it. We know the rate is miles per hour. So let's say that they told you that the car speed or velocity, we'll call it speed, is let's say 60 mph. And let's say the church is 40 miles away. How long will it take? Okay, so what do they give us? They say the car speed is 60 mph. Okay, what is that associated with it? And let's look at our variables. Is it the R, the D, or the T? Okay, let's see what the rate is. The rate is in miles per hour. What does mph mean? Well, mph means miles per hour. So this is our rate. So that is covered by R. So that's our R. So I can write it down here. R is equal to 60, and I'm going to say miles per hour. Okay. It says here the church is 40 miles away. Okay, and so I'm going to ask you the same question. Is that the R, the D, or the T? Let's see, the rate is miles per hour. This is just miles, so it can't be R. Let's see, this says miles. The D is distance, and the distance is a distance unit, and it's, in this case, we have miles, and time is in hours. So when we look at this, it says 40 miles. So which one of these two would the 40 miles be referring to? Well, if we look at the units, you can see 40 miles here and miles here, and that refers to D. So we could see D is equal to 40 miles. Okay, so we're back to the last part, so we know this is D. So they're asking for this. How long will it take? When they talk about how long, in this case, what do you think they're talking about? Do you think it's miles per hour that fits how long it will take? Do you think it would be miles tells you how long it will take? Or do you think it will be hours? They'll tell you how long it will take. That's right, it would be the hours. So in here, we kind of figure that they're talking about hours. They don't tell us what units they want, but let's give it to them in hours because they didn't specify. And this is our T. So now we have units that we, well, the variables that we found in this problem are R, D, and T. So when we're looking at this, R, D, and T, which one do we know? Well, they told us R. I'm going to circle that in blue. They told us what R is, right? We got R here. They told us what D is. That's D there. So what do we have to solve for? Well, we have to figure out what the hours is because we don't know what T is. So that is what we don't know, and that's what we need to figure out. So let's take a look at our equation again. So we have R is equal to D over T. Okay, and I like to extend things out when I need to do multiplication or division on these problems. So I need to get T by himself, and I also want him on top. So the easiest way to get T on top is if we move it over to this side. So, and you'll see why. I'm going to multiply this side by T and this side by T. And I'm going to extend our line out this way. Okay. So what do we see on this side? You can see here that we did that so we can cancel out the T. Okay, good. So now we got T canceled out, but on this side we have a T and an R. How do we get rid of the R? Well, we do the same type of thing. We're going to put R on the bottom, and since we're dividing this side by R, we're going to divide this side by R. Okay? So we divided both sides by R, so that means that we kept it balanced. And let's see what happens. You see this R cancels out, and this R cancels out. Okay, so what have we done? Well, we've got, if you look at it, we got T by himself, and now we have the other variables on the other side. So we got what we wanted. So now we know T is equal to D over R. All right, so that's our timing it. Now let's plug in the values that we know. So D is equal to, what is our D? Oh, there it is, 40 miles. Divided by the rate. What is our rate? Well, here it is. Our rate is 60. So I'm going to put 60 here. Okay, what are our units for rate? We can't forget that it's miles per hour. But since we have a fraction here, we just invert that, and the miles will stay here, and we'll put the hours on top. So it's going to be miles per hour. So all you're doing is using this and flipping it over, and flipping it over. So let's see what happens to our units. Our miles, you can see, cancels out, and we end up with T is equal to 40 divided by 60. And what are our units? See, miles are gone. Oh, it's going to be hours. And that's going to be, well, if we did this in our head, which we can do, you've got ahead and I've got ahead, and we're trying to get ahead. So the 40, you see the 10s will cancel out there, and 4 and 6, we know we can get a 2 out of that, so this becomes 2 divided by 3 hours. So 2/3 of an hour. So that's our answer. So the time that it's going to take is 2/3 of an hour. And if we wanted in minutes, we could convert it to minutes. And why don't we do that? Because converting is fun. So what do we know about hours? So what we know is 1 hour is equal to 60 minutes, right? Okay, so let's move this over to right here, and I want to convert this to minutes. So let's write that out on this side. 2/3 of an hour. And now we want to convert this to minutes. So we want to use this ratio to convert this. Now, if you have a number on one side and a number on the other side, that means that they're equal. So I can put one number on top and one number on the bottom in either way, and it's like multiplying by 1 because these are the same. Okay, so let's see what happens. Let's see if we use how we can use this. Okay, 1 hour is equal to 60 minutes. Okay, well, let's try this. I'm going to put 1 hour on top and 60 minutes on the bottom. What does our units turn out to be? I got hour and hour on top. Well, that would make my units hours squared divided by minute. That doesn't seem right because I want to get minutes. And I put minutes on the bottom. If I wanted this to convert to minutes, I would want to put the minutes on top. Okay, so I don't think this is right. So let's turn it around. I'm going to put the 60 minutes on top, and I'm going to put 1 hour on the bottom. Let's see if this works better. Okay, I got hours on top and hours on the bottom. Oh yeah, those will cancel out. Okay, I canceled those out. Okay, look, I'm left with minutes. Okay, I think this is going to work. Okay, so let's start working through this a little bit. I've got 2/3 times 60. What are the factors of 60? And I want to see, is 3 a factor of 60? I think it is, because I can go 3 times 20 will give me 60, right? 2 times 3 is 60, yeah. Okay, good. So that gives me minutes. And I'm doing that because what I want to do, and you can see why I chose 3, because I want to cancel out 3 here. Okay. So those cancel out. And what am I left with? I am left with the 2 times 20. So what's 2 times 20? Well, 2 times 2 is 4. That gives me 40. And that's our answer. Or is that our answer? Really isn't the answer yet until I put minutes there, because unless you put the units that you're solving for, you don't have a complete answer. So that's how you do a rate question. Now let's do another example where we try to figure out a different variable. Okay, so I'm going to erase this up, and we're going to use the same equation, R equals D over T. So I have I'm just going to write down as R equals D over T. Okay, so let's say the car, and I can write right here, car is traveling let's say 50 miles per hour, 50 mph. And traveled let's say it traveled 120 miles. No. Let's say it traveled 3 hours and 30 minutes. How far did the car travel? Okay, so here's our problem, and let's see if we can figure it out. Okay, so the car is traveling 50 miles per hour. Okay, that sounds important for what this is. So we're traveling at a certain speed, right? And we traveled for a certain amount of, 3 hours and 30 minutes. How far did the car travel? So we want to figure this out. How far? Okay, so let's map out our variables. So 50 miles per hour. Let's see what the units are for that. Well, miles per hour is the rate, so that's got to be our R. So that our R is 50 miles per hour. Now it says we traveled 3 hours and 30 minutes. Now looking at this, does it look like D? Let's see, D is distance. Distance is usually done in some sort of distance unit, miles or feet or inches. And this unit is in time, because hours, well, look, it's hours here. So that's a time variable. So we know what this is. This is time. Okay, how far? When you talk about far, what are you talking about? Well, most of the time you're talking about distance. So that's going to be your D. So I think we've got the variables all mapped out. So let's write down our equation. R is equal to D over T. And let's find out what we know. I'm going to write down over here R is equal to 50 miles per hour. T is equal to 3 hours and 30 minutes. Okay, we know that one. And D, well, D is equal to, they didn't tell us what D is. So we need to find out what D is. So that's our question mark. So we need to solve for D. Okay, so now we look over here and we need to get D by himself. So how do we do that? Well, I'm going to do what we did before. I'm going to put R a little bit higher, because I like to put our little brackets there, and we want to solve for D. So how do we get D by himself on one side of these equations? Well, you can see he's already on top. We just have to get rid of this T. So we're dividing by T on this side. In order to cancel out, what do we have to do? No, we don't add. We don't subtract either. Okay, that's right. We multiply by T. So if I multiply by t on this side, I have to do what on this side? I have to do multiply by t on that side. Okay. And what happens now? Well, that's right. Your t's are going to cancel out. And look at what you have. You have d by himself, which is exactly what we want. So I'm going to write that over here as d equals rate times t. Now I'm going to plug it in, and I'm just going to rearrange it because it makes it easier. D is equal to the rate. What is our rate? Oh, there it is. 50 miles per hour. Okay, so we've got our rate, and so that's right here. Okay, good. What about our time? Oh, well, our time is 3 hours and 30 minutes. Wait a minute. I only have hours on the bottom, and I got minutes over here, hours and minutes. So what do I have to do here? I know, let's convert it all to minutes. No, that's not going to work because I'll have hours, and if I have just minutes on top, well, that's not going to cancel out. Okay. All right, well, what if I converted the minutes to hours? Okay, well, let's see what happens if I do that. 30 minutes, and we know that 1 hour is equal to 60 minutes. So how do I use this ratio here to put it in the units I want? I want hours on top. Okay, so I'm going to use that. I'm going to say, I'm going to put hours on top because that's what I want. And I'm going to put the minutes on the bottom. 60 minutes. Let's see if that's going to work. Hang on. The minute on top, minute on the bottom. Okay, I think that's going to do it. So minutes cancel, and I get 30 over 60 hours. Well, we know 30 over 60 is the same as 1/2, or 0.5 hours. So when I look at time is equal to 3 hours plus the value that we just calculated right here. And we have t equals 3.5 hours. Okay, good. Now we got something that we can use here. So t is 3.5 hours. Where are we going to put t? We're going to put t on top. Okay, so if we're going to put it on top, we're going to have 3.5 hours on top. Okay, let's see if that's going to work. Distance is equal to 50 miles per hour times 3.5 hours. Oh, okay, what happens here? Okay, our hours are going to cancel out, and our distance is going to equal to 50 miles times 3.5 miles. Is miles a distance unit? Does that match up? Distance in miles? Yeah, that works, because miles is a unit of distance, so I think we've got it. So if I've got 50 times 3.5, let's multiply that out and I can do it in this order here. So I got 0, 5 times 5 is 25, 2, 3 times 5 is 15, 16, 17, and I end up with 175. So you can see our D is equal to 175 miles. And that's exactly what we're looking for, because we need to know how far we were going. That's a distance. Our answer is in miles, and that's a distance. So we set up our problem the way we wanted to, the way we needed to. So that's how you do a multiple equation for that. So this is a little bit different. We're going to be looking at area. And area is equal to 1/2 base times height, and that is the area of a triangle. And we can figure out why it's 1/2 base times height, and we can do that after we go through this example. But here we have base times height. I always like to draw a picture of something so I can understand what we're talking about. When you draw a triangle, here's our base, and so we're looking at this length here is our base, and we have that length. And then the height goes from here to here, and that's your height. And so this distance here is h. This distance here is your base. So that's where your base and height come from. So now we drew it out, and so now we kind of understand what we're looking at. So let's say we have a triangle, and let's say the base of a triangle is 4 inches. And let's say the height is 1/2 inch. Okay, and what is the area? Okay, let's see if we can map out our variables. So the base, and they tell us right here, the base is 4 inches, so that's our B. The height is 1/2 inch. Okay, that's going to be our height. And what is the area, and what is that? That's RA. Okay, so we've got all of our variables mapped out. So let's take a look at that. So A is equal to 1/2 base times height. And let's draw a picture of that just so we can understand what that's going to look like. So if this is about 4 inches, and that's our base, the height is about there. This is 1/2 inch, and that's our height. Then this is what our triangle looks like. It's not going to have a really big area. So you can see that the area is going to be this times that, which is what we have here, times 1/2. So let's plug into our equation right here. So A is equal to 1/2, 1/2. I like to use that little brackety thing, and I need to put the base on top. Our base is 4 inches, so let me write that down. Base is equal to 4 inches. Height, h, is equal to 1/2 inch. Okay, and area is what we don't know. Okay, so the base is 4 inches, so I put 4 inches here for the base, 4 inches, 4 inches, and the height is 1/2 inch. So it's going to be 1/2 inch is our height. So this is our height, 1/2 inch, and that's where we got it from here. So let's see what we end up with. Area is equal to 1. Well, let's multiply it out. I end up with, let's go ahead and do this really quick. Let's multiply the top. 1 times 4 is 4, times 1 is 4. So I have 4. And let's look at the units. The units are inches. squared. And we're dividing by 2 times 2 is 4. Okay, so if I have area is equal to 4 inches divided by 4, well, you can see right away that the 4's are going to cancel out, and I'm left with 1 inch squared. Now, when you talk about area, area's units are in a distance squared. So inches squared fits the units that we would want for an area. So that's how you do it. And so this is a pretty straightforward problem. We'll do one more, and we'll see how that works out. And we are going to say here that the area of a triangle is 100 inches squared. And let's say the base is, let's say, 2 inches. What is the height? Okay, so if we drew this out, which it's always good to do, the base is, let's say it's 2 inches. And we can see by the area, the height is going to be something pretty big because I got to multiply something by 2 to get to 100. So I know that the height is going to have to be something pretty big because I know the area is equal to 100 inches squared. Okay, so now we intuitively know that we need to end up with a big H. Okay, so let's take a look and see what we have. We have A equals 100 inches squared. The base is equal to 2 inches, and we already know that the height is what we need to find. Okay, what's our equation? A is equal to 1/2 base times height, so it's going to be I just kind of drew it out so we can see it a little easier. I'm going to put the A on top a little bit higher, and I'm going to use that little framing technique that we do. Okay, I want to get H by himself on this side. What do I have to do? Well, I got to get rid of the B, and what do I have to do on here to cancel out B? Multiply, divide, add, subtract. What do you think? Got the B on top, so to cancel them out, I need to put the B on the bottom. So I'm going to have to do the same thing on this side. I'm going to put B on the bottom. Okay, good. Now I can cancel him out. Okay, we're done. Oh, wait a minute. I've got this 2 on the bottom. I need to get rid of him too. So I know what I'll do. I've got the 2 on the bottom. To get rid of them, I have to put a 2 on top. And on this side, I'm going to do a 2 on top. And I did the exact same thing on each side, 2 on top and a B on the bottom. Okay, good, good. So now I can use that to cancel this 2 and this 2. Now what am I left with? Well, I've got 1 times H. That's going to be H is equal to 2 times A is 2A divided by B. All right, let's plug in what we know because we know what A is and we know what B is. So H is equal to 2 times the area. Oh, there it is. Area is 100 inches squared. Okay, good. So far, so good. And got B. The B is our base. It's 2 inches, and it goes on the bottom. 2 inches. Okay. 2A, 2 times A, that's 100, and 2 inches on the bottom. The base is 2 inches, the base is 2 inches. Okay, I think we have it set up. Okay, so now let's look at the units really quick. I've got inches squared and inches on the bottom. Well, I can cancel out one of those inches because inches squared is the same as like anything else, inch times inch. Okay, so we cancel it out one of those inches. So we're left with inch. And let's see if that makes sense. The height being in a unit of inches, does that make sense? Yeah, that makes sense because the height would be in inches, the base is in inches, so I think the units are all set up okay. So let's see what we end up with. I end up with, what's 2? Oh, look at this. I've got 2 on the top and 2 on the bottom, and if I have the same number, top and bottom, I can cancel him out. And I'm left with the height being 100 inches. And the units match up, and I think that's exactly what we're looking for. And that's a really tall triangle. So, and that's exactly what we expected. We expected the H to be pretty big because the base was pretty small and the area was pretty large. So intuitively, we can think that it should be a large value for H. And that is our multivariable. I will take a look at others in our lesson in the next video.